Alright, in this video we're going to learn how to use the converse of the Pythagorean theorem. Now the converse of the Pythagorean theorem states that if c squared is actually equal to a squared plus b squared, then triangle ABC is actually a right triangle. So you're given a diagram, but you don't know where the right angle is. You can assume it's here, but you can't say it's for sure a right angle because there isn't a box. So using the converse of the Pythagorean theorem, if you check to see if the longest side squared is equal to the two legs squared, the sum of the two legs squared, if that's true, then we can say it's a right angle, or a right triangle, so then we can put a right angle across from C. So then in example 1, we have to verify if this is a right triangle or not. So using the given sides, can we say this is a right triangle? Well, we have a length of 6, 9, and 3 root 13. We have to first establish to see what's the longest side. Okay, so I can clearly see that this is a 6 and a 9. 9's bigger, but then it is 3 root 13 bigger than 9. So I'm going to multiply out 3 times root 13, and in my calculator I get 10.8167. So then 3 root 13 is actually my longest side. That's going to be labeled my C. The other two legs are going to be A and B. So then I'm checking because I can't see a right angle across on the longest side. I don't know if this is a right triangle or not. So then using the converse of the Pythagorean theorem, c squared, well, I don't know yet, is that equal to less than or greater than a squared plus b squared? So I'm going to substitute in what I know. My c, my longest side, is going to be 3 root 13, so quantity squared. A squared is 6, b squared is 9, so I have 6 squared plus 9 squared. Simplify further, 36 plus 81. And then when I square 3 root 13, that actually means 3 squared times root 13 squared. Okay, so if I simplify further, 3 squared means 3 times 3, so that gives me 9. And then root 13 is root 13 times root 13. And then when I square a square root, okay, the square root sign actually goes away. So then if I add 36 and 81, I get 117. So I'm double checking to see, or I'm checking to see if c squared is equal to a squared plus b squared. A squared plus b squared is 117. C squared is going to equal whatever 9 times 13 is. So 9 times 13 is 117. Dropping down my 117 again. The appropriate symbol to put in between these two numbers is equals. So then because c squared is equal to a squared plus b squared, we can say that this triangle is a right triangle. Now we can classify a triangle by its angles using its side lengths. So there are going to be 3 different cases where you have to identify what kind of triangle it is by the angles. So if we say that c squared is actually equal to a squared plus b squared, then the angle across from the longest side, angle C, is going to be 9 degrees. So then triangle ABC is a right triangle. Now, if c squared is less than a squared plus b squared, then the angle across from the longest side is going to be less than 90 degrees, and triangle ABC is an acute angle. And then finally, if c squared is greater than a squared plus b squared, then the angle across from the longest side, angle C, is greater than 90 degrees, and triangle ABC is an obtuse triangle, excuse me. Alright, in example 2, we have to classify the type of triangle. So the first part of the question, we have 2 questions in this one. Can segments with lengths of 2.8 feet, 3.2 feet, and 4.2 feet actually form a triangle? Without actually looking at a picture, we have to figure out, well, can these lengths make a triangle or not? Just because we have 3 dimensions, it doesn't mean that we have, or 3 lengths, doesn't mean that it can actually make a triangle. So let's take the longest side first and lay that out. Again, this is not an accurate 4.2 feet. I'm just going to estimate using the numbers. So this line will represent 4.2 feet. Now, if we think about it, if we were to make a triangle from this bottom line, if we were to draw a line, it must connect somewhere above 4.2 feet, like the line itself. We know that one of our lengths is 2.8 feet, and we know that another length is 3.2 feet. And obviously we're not going to measure with a ruler at actually 2.8 feet and 3.2 feet. But what you can know about this is that if the longest side is 4.2 feet, each length added together has to be bigger than 4.2 feet. If it's less than it, they're going to fall short and maybe land here and here. It's not going to connect in the middle at all. Alright, so if I add 2.8 feet and 3.2 feet together, okay, it should be bigger than 4.2 feet so that it'll intersect and land like as if these are two walls trying to fall in the middle. Okay, so if they're bigger, then they should probably connect about here. So if I add 2.8 feet and 3.2 feet, it needs to be bigger than 4.2. Perfect, so then it actually equals 6. So then because 2.8 and 3.2 added together gives you 6, we can actually form a triangle. So now that we can form a triangle, we have to see if it's an acute, right, or obtuse. So using the converse of the Pythagorean theorem, we're going to use our longest side, 4.2 feet, as C, 2.8 as A, and 3.2 as B. So we're checking to see if 4.2 squared is greater than, equal to, or less than 2.8 squared plus 3.2 squared. Simplify further, 17.64, 2.8 squared is 7.84, and then 3.2 is 10.24. Okay, so we're checking to see if C squared and how that relates to A squared plus B squared. Add together we get 18.08. 17.64 is actually less than 18.08, so we say that the triangle is acute. And we could do all this without actually drawing a picture. After we know that the three side lengths are given to us, figure out if it's a triangle or not, and then using C as your longest side, which is 4.2, and use the converse of the Pythagorean theorem to do so. Alright, again, thanks for watching, guys. Have a good day.